This is a classic case of a factoring problem. Now, what factoring is, just as a little review, is taking something, some term, like this top or the bottom, and splitting it up into the parts that multiply to equal that thing. So I'll take an integer as an example. If I had the integer 6, two of its factors would be 1 and 6, because those multiply to equal 6. Another two of its factors would be 2 and 3, because those also equal 6. In the case of polynomials like this, obviously, like one way to factor the top would be to say x squared minus 9 times 1. Okay, technically that's factored, but that's really stupid, obviously. So what we're going to do is we're going to try to find the unique combination of two things that multiply to equal the top over two things that multiply to equal the bottom, and hopefully something will cancel out. Alright, so for the top, what we have is something beautiful called a difference of squares, meaning that you have a perfect square minus a perfect square, because this could also be written as x squared minus 3 squared. And we have a formula that says a squared minus b squared factors to a minus b times a plus b. I hope you can see that. It's kind of pushing the edges of the board there. So if we just kind of apply that to what we have here, we'll get x minus 3 times x plus 3. So these terms are exactly alike except for the plus and the minus. That's known as conjugates. They are conjugates of each other, just in case you wanted to know that. So that's our top factored. So hopefully when we factor the bottom, we'll either get an x minus 3, an x plus 3, or both. That would be wonderful. So there's a little bit of a different rule for the bottom. This is called a trinomial, a perfect trinomial, because there's no coefficient on the x squared, which makes life so much easier. If you run into that, that's a whole different topic. But for now, there's just an understood 1 right there, right? Right there. So for the bottom, we're going to take the x squared plus negative 6x. I'm just writing out my negatives like this because I think it makes it easier to see. Plus 9. And I'll put these two terms here in parentheses, just so you can see these are separate. And you're going to need to keep track of that negative sign there, because, you know, something minus something is the same as plus a negative of that something. Because what we're going to do now is we're going to find the same two numbers that multiply to equal this and add to equal the coefficient of this. We're not worried about the x, just the 9 and the negative 6. If you have a lot of experience, you'll see that right off the bat. Negative 3 times negative 3 equals 9, and negative 3 plus negative 3 is negative 6. If you don't see that, it just takes some practice and trial and error, trying out a few different numbers that you know multiply to equal this, and see if they add to equal that. If there's a negative sign here, obviously at least one of them has to be negative. Yeah, and if this is negative and this is positive, then they both have to be negative to cancel each other out in the multiplication and give you a positive. Anyway, so we have negative 3 and negative 3. So I'm just going to plug an x in front of there. So we've got x plus negative 3 and x plus negative 3, and they're multiplied by each other. Those are our factors. If you wanted to FOIL this out, you know, first, outside, inside, last, all that jazz, then you would get back to x squared minus 6x plus 9. So let's bring that up here into our denominator, x minus 3 times x minus 3. You could also write that as x minus 3 squared if you want, but then it wouldn't be quite so satisfying when I just cancel those out, right? And you're left with x plus 3 over x minus 3, which I believe is number 5 on your answer sheet.